Hello. In this video, we'll be looking at another type of word problem. This type of problem is a distance problem, and we'll be using the familiar distance equals rate times time that many of you have seen in previous courses. So here we have two people that are traveling to a business conference. This trip takes 2 hours for Maria and 2.5 hours for Eduardo since he lives 40 miles farther away. Eduardo travels faster than Maria, 5 miles an hour faster, and we are to find the rates. Now, distance problems typically come in three types. The first type is that the first distance equals the second distance. So in this case, Maria's distance would equal Eduardo's distance. If that's what we know, then that's the type of problem we will set up. Their distance equals their distance. Another type of distance problems involves taking one of the distances, I'm calling it distance 1, and adding or subtracting some number, just a regular plain old number called a constant, and setting it equal to the second distance. In other words, one of the distances is shorter or longer than the other distance. The third type of distance problem involves adding the two distances together to equal a certain constant. A popular kind of problem has to do with a train or a plane leaving the same place but going in opposite directions. And probably the question would be, how long does it take for them to get, for example, 500 miles apart? So we would know their two distances would add up to the 500 miles. So the first thing we need to do is figure out what kind of distance problem this is. Often a little sketch helps with that. So I've got my little sketch over here. Maria's in blue and Eduardo's in green, and they're heading to this conference here. Now, I know that Maria traveled less than Eduardo because it says very clearly that he lives 40 miles further away. So I'm going to use the second version of the distance equation. I'm going to take one of the distances and add or subtract some value and set it equal to the second distance. So if we look at what we have, we notice that because the problem says that Eduardo is 40 miles further away, we know that from where Maria starts to where I have Eduardo starting, that's got to be a distance of 40 miles. So we can set this up one of two ways. We can take Maria's distance and add 40 and know that it's equal to Eduardo's distance. Or I could take Eduardo's distance and chop off this 40, so subtract 40, and then it would be equal to Maria's distance. It doesn't matter which one you pick. I've chosen to take Maria's distance and add 40 and set it equal to Eduardo's distance. Now, how do we describe the distances? Well, here's where we use distance equals rate times time. Now, I'm a chart person. I like to organize my information in a chart. So I know that rate times time equals distance, and that's how I'm going to set my chart up. Rate is the furthest column to the left, time's in the middle. Rate times time then will equal distance. Well, what do we know about Maria's rate? Well, we don't know a whole lot. We know that Maria travels slower than Eduardo. He's 5 miles an hour faster. So I'm going to call her rate X, and then his rate would be X plus 5. We do know that Maria travels for 2 hours. We also know that Eduardo travels 2.5 hours. Now, all I'm going to do for distance is describe it algebraically. So I'm going to take the rate, x, multiply it by the time, 2, and get 2x. And similarly, I'll take Eduardo's rate, multiply it by Eduardo's time, and I get 2.5 times x plus 5. Now, remember what we've said is that we're going to take Maria's distance plus 40 and set it equal to Eduardo's distance. And that's how we get the equation for this particular problem here. Now, when we solve that, we get x equals 55. So Maria's rate, if I look back in the chart here, Maria's rate is x, so she's 55 miles an hour. So add 5, and we get Eduardo's rate.